Engineers spend a lot of time in wrestling with the tools, multiple tools. I can design it, but can I make it? I don't want to wait for 3 days for remeshing, redesigning, or simulating something. They're very powerful, but very intimidating. Or they're very easy to use, but very shallow for the engineers to start with. Engineers' job is not to spend days creating mesh or creating CADs. Their job is to solve the real world problems.
Thank you so much, Jaideep, for doing this. Today we'll talk about designing without limits, the future of engineering with implicit modeling. Today I have Jaideep on the show, so welcome and thanks for doing this.
Hey, thanks, sir. Thanks for the invitation.
Very cool. Give us a quick introduction to yourself, and then we'll talk about what implicit modeling is in the first place.
My name is Jaideep Bangal. I'm a senior director at Altair. My role is about helping our customers, our partners succeed with our design and simulation. We make sure that tools we build actually help our engineers solve real world problems. I have spent most of my career around the simulation driven design. And what really excites me is these tools, what we have, because of can shorten the product life cycles and unlock the creativity with engineers.
What does it mean concretely? So a lot of people don't really understand the term implicit modeling. So what does it actually mean, and how does it help us engineers to design better products?
One of the implicit modeling itself means a mathematical way of designing. The traditional CAD, for example, is with the surfaces, edges, solids, or volumes you design. On the contrary, the implicit modeling, you define the functions, and those functions can help you build very complex geometries without getting into the limitations of the CAD. So, within implicit modeling, instead of manually building every surface edge, engineers define functions, mathematical functions. And this really opens the incredible, as I was saying, complex but elegant designs from like lattice structures, porous media, smooth transitions that are difficult or almost impossible in traditional CAD. It gives engineers really freedom while still keeping the grounded in performance and manufacturability. That's more important at the end of the day.
You talked a little bit about the problems, Jaideep. So where do we even start from? Like, what is the problem statement? I mean, we have the traditional CAD and simulation bottlenecks, right? For example, we talk about remeshing, file format issues, etc. Like, what are the actual problems that then actually justify engineers or mathematicians having to come up with implicit modeling?
In a traditional CAD and simulation world, engineers spend a lot of time in wrestling with the tools, multiple tools. So, you create the geometry, then you have to remesh it, you make changes, you have to remesh again, and go to the simulation tool. So you are jumping from one tool to another many times. Implicit is totally integrated within the Inspire platform. That's our Altair's simulation-driven design platform. So engineers, when they design with Implicit, at the same time, they can run FE analysis to validate the performance of that new design. And at the same time, they can check the manufacturability of that new design right there within the Inspire. So instead of going between multiple tools and touching multiple tool points, everything in under one umbrella.
Can you give us maybe a couple of case studies or examples where implicit modeling really shines, especially in the practical application?
Implicit really shines in cases where the geometry complexity is tied to the performance. Think about the lightweight lattice structures in aerospace or cooling channels for the heat sinks in very high performance microchips. Or think about the medical applications or like implants. These are the geometries where CAD struggles, creating these struggles. Not only just designing, but also simulating for the performance validation and also for the manufacturing. I can design it, but can I make it? That answer, can I make it, can be easily answered by this running a quick manufacturing feasibility simulation within Inspire.
Mm-hmm. Yeah. I mean, you mentioned Inspire now, Jaideep. Maybe let's delve a little bit deeper into it. Like, when we think about the Altair ecosystem, right? Where does Inspire fit into this whole ecosystem and also the product development lifecycle?
Inspire is Altair's design and simulation kind of solution platform, right? It puts simulation right at the heart of the product development with design engineers, mechanical engineers, manufacturing engineers, very early in the design development cycle, where engineers can explore ideas, optimize them, and validate manufacturability right at the design stage. If I'm an engineer, I want to check 3 designs before the lunchtime. I don't want to wait for 3 days for remeshing, redesigning, or simulating something. And that's what Inspire gives flexibility to the design engineers.
What about like things like geometry conversion, etc.? Like I'm trying to, especially if engineers are listening to this podcast, what will they benefit from if they use Inspire as compared to some of the competitive tools, other competitive tools out there?
A lot of other tools, focus heavily on the advanced implicit modeling or specialities. Even within Inspire optimization, they're very focused design tools or optimization tools or the simulation tool. That's great. But Altair's approach with Inspire is different. We are not building another very point tools where we go only for CAD or only for simulation or only for manufacturing. We are embedding implicit and the Inspire in the broader ecosystem of Altair, from designing, from optimization, from simulation of AF analysis, from manufacturability. It's for the multitasking engineers, one-stop shop to do all what he or she needs, from designing to the manufacturing.
There's a term called joined up modeling. What does this actually refer to? What are you guys referring to, especially Altair, when you mentioned joined up modeling?
So this is what we call joined up modeling, with design, simulation, and manufacturing all speaking of the same language. It means engineers focus on solving real world problems, not spending days trying to remesh or trying to go to the different tool, learn different tools. Everything is in one single place. We, instead of engineers try to use or teach different tools, we did that job running Altair solvers, which are very high-end solution solvers, which are being used by automotive, aerospace, you name it, for many 30, 40 years. But with Inspire, we made very easy to use under one umbrella. That's Inspire. That's where the industry is headed. Where giving more power, empowering the engineers, designers, manufacturing engineers very, very early. And Altair is pushing really hard to make it real.
When we look at real world use cases, Jaideep, and your market positioning, right, especially now after the acquisition of Siemens, I'm wondering, when I go on LinkedIn, I see everybody, especially in the simulation space, says the same thing, right? Faster time to market, acceleration of simulation, etc., etc. But how does your tool, especially like in this whole Altair ecosystem, how do you guys set yourself apart from the rest of the people in the market? Like, we don't have to mention any competitive tools, but like, what is your USP, so to speak?
So most tools fall into one of the two categories, right? They're very powerful but very intimidating for the engineers to start with, or they're very easy to use but very shallow. They don't have the breadth of the features and the capabilities. Inspire with Altair bridges that gap, where it has horsepower of all the Altair's physics solvers and the meshing technology that runs in the background. Engineers don't have to spend time on that part, but it's a very intuitive environment where the GUI, the workflow is very, very intuitive, where even a designer and a student can be productive very, very quickly. And it directly ties to the manufacturing process simulation that's Altair's platform builds. So we are not just creating designs that look great on screen, but we are actually making the design that can be built. That's a big differentiator between the other tools, where they can be in either one camp or the other camp. Inspire covers the entire spectrum from design to manufacturing.
Yeah. Can you talk a little bit about maybe some success stories that you've personally followed?
Oh, okay, that's the interesting one. Let me see. There are a bunch of success stories. You drive a car every day, you fly on a planes every day. Every single part that goes on the plane, pretty much, or the car, is being optimized or touched by one of the Altair tools, right? Give or take example of Airbus 380. We shaved tons and tons of material just by doing optimization. Of course, the Airbus engineers did it, but they use these tools. Without that, that plane will never take off. Or same with, let's take example of mega castings, right? We heard about mega casting, giga castings. It's massive setup to make these solutions or the parts, right, from the OEMs. So before we actually cut the metal or we try pouring the metal, we want to know, if I make this part, what kind of defects I will get, right? And many of the OEMs, automotive side, they use these manufacturing tools, let's say casting, to check what kind of porosities we'll get, what kind of defects they might get, where should be the gating system. So that's optimizing the manufacturing process. The second part is, now I have my virtually manufactured part. Can I take that data from, let's say, porosity data from casting and use for the crash analysis to see, if I manufacture this part with casting on my car and it goes into a bad situation like crash, what will happen, right? And that all can be simulated, and they are being simulated by all the cars and the planes and consumer goods you're using. Another example I'll give you, Joseph, is refrigerator, right? We all use refrigerators. You know, 30 years back, refrigerator walls were like that thick. Now you think they're really tiny thing. They use something called polyurethane foam, and very easy chemical reaction there, but very complex to simulate. So most of the refrigerator manufacturing companies use these solutions to identify or optimize the manufacturing process with the polyurethane foam. Can I get thinner, but it has the same exact performance? Maybe out of 10, 8 top refrigerator companies in the world, they use Inspire's polyfoam or Inspire polyurethane foaming simulation for that matter.
Who would you advise should actually give Inspire a try if they don't use it already?
So, in my opinion, every engineer or a designer who creates new designs, new parts, they should try Inspire. One for the design optimization, FE analysis. And we are engineers. We want to create design, but our job doesn't stop there. We might be multitasking engineers. One day sitting in front of computer, next day we are in machine shop trying to figure out manufacturing. So that engineer should try the entire process from designing to manufacturing on virtually, and that's Inspire brings it to it. Implicit modeling, right? If you're not the expert in just designing or coding or running tens of scripts, but you have a real job of designing parts and you want to try the implicit modeling like lattice structures or porous media, or maybe, as I said, in medical applications like implants, you should give a try because Inspire brings the usability for the engineers. You don't need to be expert in these tools. You are doing your job, and these tools are helping to make your job easier. And one thing I'll also mention, not sure I'm going to ask this, there's a misconception about implicit modeling is only for 3D printing, right? We are saying our customers are going beyond 3D printing. Implicit modeling is a way of designing. It's a mathematical equations that help engineers give that freedom or flexibility to create designs which are very complex, but at the same time very smooth and easy to make and very scalable. We're seeing companies in jewelry, even in automotive aerospace, defense, as well as a lot of medical application. They are using the implicit model with casting. It gives a complexity of creating a cooling channels and making the dies very small. Or think about the heat sink is a good example of microchips. It gives you a very very complex heat sinks, but you don't have to be manufactured only with the 3D printing. Flow analysis, fluid systems. We can check these fluid systems, creating very high performance for heat exchangers, flow channels, which can be manufactured the traditional way, but you can also design those. We can also check the fluid performance like pressure drop, temperature, all that within the same environment of Inspire using implicit models.
Now, that brings me to my next question, Jaideep, which is about artificial intelligence. So what is possible with AI when we talk about implicit modeling plus AI? And what is not possible?
So AI is already starting to add a lot of value in areas like design exploration. The design exploration, think about, you have the bombs, you have a goal of pressure drop, or, very complex heat sink, or how the temperature, heat transfer, or the temperature number for those heat sinks. Those are already there. The AI is already helping in these sorts using implicit modeling. Now, think about going to the next step of manufacturability. As engineers, we have tons and tons of data, existing data from manufacturing simulations over the last few decades. We can use that data to train the AI modules to predict the failures for the new designs within few seconds. And that's AI is already contributing to that part. Of course, there can be done much more in the future, like convergence, right? Engineers set an intent and the AI will come up with that design automatically. Is it going to happen? Maybe, maybe not. But that's where everyone wants to go. That's where the future lies, or that's the exploration is at. So AI really accelerates the exploration, and the physics validates everything. That's where we are today. Design exploration side and the physics for the manufacturing side.
Looking into the future, Jaideep, I think it would be very interesting for the engineers listening to this podcast why engineers need modern tools.
That's a great question. And when I went to school, I started designing everything with the drafting. My first CAD tool was AutoCAD in 2D, where we assigned to XYZ coordinates. My next tool for the simulation were the creating mesh really manually, every element manually with XYZ codes. And now you see, you click the button, the mesh is created. The CAD is very intuitive. So there's evolution in the all the areas, right? From the CAD side, from the simulation side. And the engineers have the tools. Engineers' job is not to spend days creating mesh or creating CADs. Their job is to solve the real world problems. And these tools, the modern tools, help engineers exactly in that area. All the technology is there in the background. They're helping, guiding engineers to make the right decisions, design decisions, manufacturing decisions using the simulation. And that's where engineers need to adopt the new technology, where it's out there. Spend your time, which is really valuable these days because each company wants to cut down the product development cycle. They want to cut down the cost and be efficient and be innovative, right? They want to be unique from everyone else. And these tools help engineers to really answer those questions.
Yeah, I feel there's a lot of marketing fluff. Like as an engineer turned marketer to some extent, there's a lot of marketing fluff out there, especially when it comes to AI. How do you think engineers should be should basically cut through the noise? Because there is a lot of everyone is doing AI right now, and we talked about why Altair, why Inspire, right? So, how can engineers tap into this world of Inspire in the Altair ecosystem?
We as an industry need to really stop marketing these tools as a very dry, feature heavy, like 100 capabilities, solving easy button type. No, engineering exciting. I'm an engineer. My son wants to be an engineer. It's about creativity. It's about innovation. Who's engineer? Engineer is the person who solves everyday problems for common person, right? Anyone can be an engineer at that point. If we can tell the story, that story better to everyone, will attract next generation of talent from high school students or anyone to really get into engineering and inspire people to build amazing things that has to be done. We look around. There are innovative things every day, from rockets and the electric cars or autonomous cars. Engineering is amazing, but I agree with you. We need to change our marketing perspective, not for just for the products, but as the engineers for the next pool of engineers.
Absolutely. Maybe we should tease it that there will be a deep dive session with some of your colleagues on Inspire. So we will actually see it live in action, which I'm super excited about. Jaideep, to wrap up the podcast, what would be your 3 tips to the engineers out there? Not specifically for the Altair ecosystem, but just general engineering advice from your side. Because you've had a long career, or you're still having a long career ahead of you. What would be your advice to the engineers out there that need to adapt nowadays?
First, I'll go back. So, as you mentioned, there's a deep dive sessions. So definitely join. We'll talk about more implicit modeling in details. Well, a couple of my colleagues will actually demo the implicit modeling, an entire ecosystem of Inspire, where they're designing with implicit, running FE analysis simulation on those implicit, and manufacturability check right there in under some one single tool. I actually do a lot of guest lectures, and in students there ask me that question, Yosef, is what's next? Is there a future for the engineers? Absolutely. Don't worry about AI. Don't worry about that the jobs will be there or not. AI and all these tools are going to help us actually move very, very fast. I would say 3 things we mentioned to for the next generation of the students is keep exciting, be innovative, all right, and get out of your comfort zone. Break that glass ceiling, get out of that box where traditional way of designing is only of way of designing. Think about the traditional way of designing is the Legos, where blocks and you're building the blocks. This new way of designing with implicit or inspire is, think about, you have a clay in hand and now you're molding something with the clay. So it's totally different thinking that what we sometimes will learn in the school. And the last one is keep pushing the boundaries. That's really going to really help.
What separates, maybe last question, Jaideep, then I'll leave you alone. What do you think separates the good engineers from the great engineers? Do you think it's curiosity alone?
It's a curiosity, of course, right? It's a thinking outside the box. I keep saying that again, maybe. There are engineers who maybe only thinking about making something and just moving to the next phase of designing, or I just need to get this one done. My project is done. It's not that. thinking the holistic way of the application, the component, the part. Take example of 3D printing. Everyone thought 3D printing is magic or you're going to solve the problem. But there are advantages of 3D printing. Can I consolidate 10 parts into one single part? You saw some rocket engine example. That is what engineers need to think about. And that's what the innovation is about. That separates what the traditional engineers taking the same exact part and trying to use maybe different manufacturing process than some engineer thinking, let me step back, go to the basics and see what else can be done. And the person who actually thinks about that way is really a innovator or the creator of a next generation of engineers.
Absolutely. I think that wraps it up. Jaideep, thank you very much for this short but very crisp podcast. And I'm really looking forward to see your colleagues presenting Inspire and what we can do with implicit modeling in 2025.
All right. Thanks.
Thank you so
It's
much.
always fun.